So here we just have another example of an inelastic collision, and this time we're going to take it just the natural step further and use a little bit of energy conservation after to determine what happens. So we have a 5-gram bullet that's fired at 425 meters per second into a 50-kilogram block, and that block's hanging from some wires as shown in the picture. We want to find the velocity of the block immediately after the collision and the maximum height of the block. So to do this, we're first going to use the conservation of momentum before and after the collision to determine the final velocity of the block. Then, from after the collision to the top of the swing, we're going to use energy conservation. So the final velocity of the block is going to give you the kinetic energy of the block after the collision, and we can use that to determine the height that the block will swing by setting it equal to the potential energy. So the initial momentum is equal to the final momentum. We know initially that the block of wood is not moving, so it has no initial momentum. We know the mass and the velocity of the bullet. And so the velocity of the block after the collision is 0.0425 meters per second. We can now use energy conservation, knowing that all of this kinetic energy will transfer to potential energy at the top of the swing, to solve for h. So we find the height of the top of the swing, 0.000092 meters, or 0.092 millimeters, or 92 micrometers. So a very, very small amount of height. And this is due to the extreme difference between the block of wood and the size of the bullet.